This is stream number 5. What are we doing today? We're learning how mail parser works for writing the syntax for GIF files. I guess that's still applicable. Yeah, where I left off yesterday, I was working on application extension. I thought we actually parsed through the whole thing, but I think I'm wrong about that. The reason I think I'm wrong is we're reading the block size, and then we're reading the block size again. I'm like, oh, wait. Don't we need to actually read the content of the block? That's because of this to-do. I guess I was thinking that this bound would work, but it doesn't, so... Oh, wait, maybe it does. Oh, no, I'm wrong. It does work. So that is a trailer, right? Yeah, okay, so let me look at... So it is parsing the application block. And the block after has a different extension and label. 33,255 and a 33,249. Okay. So I guess the way in which we're deciding that something is a application extension... Oh no, it's by the label, right? Okay. Oh no, it's this, right? That's probably wrong. Let's see how this works. We'll look at the table here. So label of 249, that's a graphic control extension. So is the first byte always 33 then? Or 21 hex? Protocol block labeled by the extension introducer, 21 hex. 21 hex defines an extension. Always? Looks like it. Okay, so that tells me that probably what we should do is say that this isn't extension, it's yeah, well what else could that first byte be other than an extension? I guess that's my question. So like something that's not an extension. Okay, these are both extensions. Graphic rendering block. I think everything is an extension. Okay. So then it's okay, then I think I know what I'm supposed to do here. We're supposed to branch on the label, right? So really I should be taking this off and putting it here and say if it's equal to, then it's an application extension, and we no longer need to tell it its label because the label is used to identify that's an application extension, right? We just need to have an else here. Let me assume that all extensions operate the same way in that they have after the extension and a label, they have a block size, some bytes, right? And then some data blocks. So if we say like unknown extension, and we format it similarly to an application extension. We call it an unknown extension. We remove this condition, and then we do a skipping of like block size times 8. And then data blocks. Let's see if we can get through the entire file this way. Might not work, but you know, why not? Why not try? Unable to parse it. Syntax error on 103. Right there. Okay, what's my syntax error? Do I have to have some thing like that? Nope. It didn't like character 6. Oh, the semicolon? There's no semicolon there? I thought there would be. Nope, there's not. Oh, it got all the way down to the trailer. Look at that. Oh, that doesn't look right though. 425 data blocks? Or, yeah, datas? That can't be right. Skipping 8 million extra bits at the end of data. Okay, yeah, it's not parsing it correctly. So after the global color table, what do we got? Skipping 24 bits at the end of a bounded region. I think that's fine, because that probably goes with this first one here. We're skipping those 3. Okay, here's where I'm not sure if this is going to work. So if that is a block size, we do skip it, and we have a trailer. Yeah, I don't think that's correct, because that's not an extension, right? So that means we can't just like say, hey, we can parse any unknown extension. So just out of curiosity, what does extension 249 actually look like? Graphic control extension, right? What does that look like? Graphic control extension. So yeah, it's got that thing. It's got packed fields, block size. Block term. That should have worked. Why didn't that not work? Right, it's 4. 1, 2, 3, 4. And then a block terminator. Okay, that did work. Extension 44. Okay, so it's that whatever's following after it is not an extension. That's what it is. So a value of 44, what is that? Okay, look here. 40, oh, there it is. It's an image descriptor, and it's not an extension. Okay, so does that mean all extensions have the same extension introducer? Image separator. Identifies the beginning of an image descriptor. Okay, okay, okay. Okay, so yeah, then this is wrong. This is like, this is more like a type thing, right? So how did we end up parsing it? Oh, we just assumed that there was no more bytes to it, right? So I think that means we have to have an else. And this is not an extension. This is like a type field or something. Extension. We'll have an else field with an error, because if we reach like an unknown data, we don't know how to parse it. Like if we didn't know about this image descriptor, we wouldn't know how big it is, because there's no built-in size field, right? So that implies we have to know what the size of the image descriptor is. And if we don't, if we haven't been told about what the type is, then we have to assume we don't know how to proceed. So error unknown data. Okay. All right, so parsing it like that, I should get that unknown data at the end. Yep, unknown data. So it parses the unknown extension, but then it reaches the unknown data. Can I like, I forget, can I like actually append the type of type and then add to it? I don't remember if I allow that in my syntax. Oh yeah, look at that. Unknown data of type 44. Cool. Hey there, Sarian. How are you doing? So Sarian, I saw the discussion in the Discord about, or the responses you had to the ChatGPT stuff, and
okay, the main floor is on. By the way,
that was weird. My phone decided to turn on the speakers outside from what I said. I'm not talking to you, Siri. Anyway, I posted in Discord about what I asked GPT about how to replace my parser generator with something in Rust, and it recommended nom. I actually ended up afterwards pressing that regenerate button or the save and submit button. It gave me a completely different answer, which was it proposed Lawler or something. Rust Lawler Pop. Actually, that's a pretty cool name when I think about it. So yeah, this is the other recommendation ChatGPT gave me, along with a bunch of like overview and instructions and stuff. So yeah, from what you said in Discord, it sounded like nom isn't something that I want, because I'm going to have a separate lexer anyway, so my input is not going to be either bytes or characters, it's going to be tokens. So maybe Lollipop is more suitable. I haven't looked into it to see is its input tokens or not. If it is, then maybe it's more suitable. But yeah, that's looking like a promising candidate from the little that I know about it. Yeah, Lollipop was another one you're trying to remember. Yeah. Does Syrian sound like Siri? Maybe. Okay. So minimally, we need to define type 44. I kind of want to get it to parse through the whole file, and then we'll fill in the to-dos. So whenever we reach unknown extension, we want to remember to go back and do that. Do I have a... Let's delete this for a second. Do I have a way to do a warning? Like warn? I don't remember, but I can look. We have error, right? Do I have a warning? Error, but I don't have warning. That might be something I should add, right? A kind of a statement where it doesn't stop the parsing, but it like emits a warning message. We add that to the to-do list. Consider adding a kind of statement that emits a warning and continues parsing, unlike error, which stops the parsing. Okay, gotta try to stick to that habit where if I think of something I might want to do, I immediately should go to the to-do and write it down and at least say consider. If not, outright do it. I've been the Raging Python. Hello! Unfortunately, we're not doing Raging Python here. We're doing coding in my own domain-specific language for parsing. And we don't have a way to do warnings yet. We'll just have to like look out for unknown extensions. Okay, but we were finding out just now that we need to be able to understand data type 44. So we're going to put it in here. Else if type equals, now 44 is, I guess I can just put 44. It's this image descriptor, right? And it's marked by this image separator. Right, it's 2C, that's what it is. 2C is 44, right? 2 times 16 is 32, plus 12 is 44. Actually, I don't really need to put a comment here, right? Because if I just read in the body, I see that they're extensions. In fact, it might be better to say extension here. Maybe, maybe not. Depends on how I want the report to be structured. Okay, type 44, it's an image descriptor. Okay, so then we want to have image descriptor. Don't need this one anymore, right? Trying to make use of these bookmarks. So let's put a bookmark here. Okay, so it's image separator, it's a byte, and then left top width height. I just had a thought. When they define the syntax of an image descriptor, if they include that image separator, that kind of implies that the top level loop here should not consume label and type. Actually, the label doesn't even go there, right? Label's in the extension. It shouldn't consume the type. It should kind of just look ahead, and then when we get to image descriptor, then we name it, right? Maybe I should go ahead and do that. So yeah, that would be that we, well, yeah, it would be that we don't actually retain this. So kind of like what I did at the top level, right? I did one of these things and I had a local. So over here, that was don't retain it. It's local, and then store it in type so that make type a local, like that. Which means that yeah, here it was called in the extension. It actually had a name. Or was it a look ahead? It was a look ahead, wasn't it? Yeah, it was called, so it would, yeah, it's called extension introducer. And then there's an extension label. Okay, extension introducer. But then again, hold on. That was always defined as part of the actual extension, right? So if I want to be true to this, then I kind of want to have it look ahead again, right? So something like this, local label, and then ignore, but parse as an extension label. Look ahead. Store in label. And then do that. And then I would define extension label in a certain way so that it actually ignores the first 8 bits. And then returns the UI label 8 return label, right? Which is itself a look ahead, so that we rewind back, so that in an application extension we can specify it exactly like they do. Say it's an extension introducer extension label, and then actually do a check. Introducer 8 extension label. It might seem redundant, but I think I kind of want it to look exactly like it does in the spec, like pedantically similar. So yeah, it would be like we would have 2 checks here, right? The extension introducer has to be what they say it has to be, because they actually do say that it's a fixed value of 21, right? 21 bad extension introducer. And then they say that the label for application extension has to be FF. Yeah, so they actually name it application. No, they call it extension label here, and then down here they say application extension label. That's inconsistent. Maybe they meant to say application extension label, or maybe it doesn't fit. I think I should try to be consistent with how they define it down here. So this would be application extension label. FF. Okay, so let me hit the other. Do I have the other extension in here? Well, I have unknown extension. You know what I'll do is I'll just do this where we don't know what it is. There's an introducer and a label. Right. Okay, so then okay, where were we? I had 2 image descriptors. That should go here. I think I was in the middle of writing the image descriptor. Right, 2C. Image separator. Right, so now that aligns back to what I have here, because like this local type will be 2C, and then we have to reparse it as an image separator. So that means I do want to have a little check here, right? A constraint that says it has to be 2C, and we would say bad image separator. Copy and paste. Okay. So then there is no more to do, right? Because the that image descriptor, where was it? Right. It ends. Oh no, it doesn't end. There's packed fields. I'm gonna cheat and just copy them and paste them down here so that I can just look at it while I'm writing it. So it's a bit, which is local color table flag, and then interlace flag. So a bit interlace flag, and then another bit sort flag, and then reserved. So I kind of like having, we just ignore it. Oh, we can't give it a name to reserved, right? And then size of local color table. Local, actually, why am I typing this? The global color table had the same kind of stuff in it, right? Yeah, this thing. This thing is a color table size, right? And this is local color table size. And probably like the global one, it'll say like if that bit is set, then a local color table follows, right? Immediately after this image descriptor, exactly. So it kind of works the same thing as the global one. This thing, right? Now maybe we shouldn't consider that part of logical screen. Maybe that should actually be outside, and it should be here. Let me think about that. Like, how is the main syntax defined? Oh, yeah. So there's something called logical screen and then logical screen descriptor. So maybe I should break it down like that. Logical screen, and then this is the logical screen descriptor. Kind of like this. We would like return the what we need, which is global color table flag, right? And then we will say like local that, and then we would have logical screen descriptor. We should probably put that after. It goes down here, right? And we're returning it. So that means we would say what the first thing is that, and then store it in the global color table flag. Then if it's not 0, we have a global color table. So kind of the same thing for the image descriptor, right? How's that actually defined? They call it table-based image. And it's part of graphic rendering block, which there's a graphic control extension. Oh, okay. So this sort of implies that if we either see a graphic control extension or an image descriptor like tag, then we should go into graphic block and then look again and see, well, do we start with a graphic control extension? If so, parse that and then go into graphic rendering block, which should expect either a table-based image or a plain text extension. And if it's a table-based image, then we have an image descriptor. And then that returns whether or not there's a local color table, and we parse local color table. Hey there, Nightshade dude. I'm trying to arrange the syntax for my GIF parsing to kind of match the grammar in this official spec. It's a little weird because when they just find the grammar this way, like I kind of have to write my parser to kind of be like a look ahead grammar. Because like when they say like you could have something or something else, that means you kind of look ahead and see, well, is it that thing or is it that thing? And if it's that thing, then parse it. It's like you have to look ahead to detect what you're about to parse, right? So yeah, in data, I really should be doing this check, right? We do a look ahead and we can determine whether it's a graphic block because it's either going to start with an extension or it's going to start with this thing, which is either a table-based image or a plain text extension, and this thing is always a image descriptor. So a graphic block starts in one of three ways, right? It's either a graphic control extension, a plain text extension, or an image descriptor. One of those three things will mark that it's a graphic block. Otherwise, we know it's a special purpose block, and so we would expect either application extension or comment extension. All right, so how do we code that? Not like this, right? Well, there's a look ahead, right? So it's that we should have one of three things it could be, right? Or so let's figure out what those three things are. If it's one of three things, then that means it is a graphic control block, right? Otherwise, it's a special purpose block. Okay, what are the three things? Obviously, they're not all 21. What are they? So one is graphic control extension. Graphic control extension is that the label is F9, and it is an extension. So I guess we have to look ahead 2 bytes. Not 1 byte. Where was I? Where was I? Where was I? Was right here. Okay, so then let's have like another thing here called like a look ahead. And we're going to store into that, and it's going to control its own bound, and we're going to call it like let's call it what it is. It is a data block look ahead, right? Or it's a data look ahead. And it is to be ignored, and it is just a look ahead. And so this would be like, there's going to be like 2 combinations of things, right? So let me make it easier to read by doing it this way. Because it's going to be like look ahead paste dot first and second, right? I forget what that second byte was for a graphic control extension. Graphic control extension. F9. Okay, so what's the second thing it can be? It could be the beginning of a graphic rendering block, which is, it could be the table-based image or a plain text extension. So let's do the plain text extension first. What does a plain text extension look like? Plain text extension. It's an extension with a 1 for a label. So it's like this, only instead of F9, it's 1. Oh, 1. Okay. Third thing that can be, it could be table-based image, which starts with an image descriptor, right? And yeah, that image descriptor was just that we have an image separator, which is a 2C. So that would just look ahead at 1 byte and say it's 2C. There we go. So these are the conditions in which the data is a graphic control block. If it's not a data control block, it has to be a special purpose block, right? So let's terminate that. Yeah, this, we don't need any of this anymore, right? Actually, some of this will become graphic control blocks. So let's start doing graphic control block. Actually, it can inherit the look ahead, right? Then I don't have to look ahead again. Right. Just thinking like that means look ahead is going to be in the report for graphic control block. It would be nice maybe if I could say like, I don't care about it, so put a minus in front. So don't include it in the report. Might want to do that. Which means I want to have a to-do here saying, consider syntax for making an argument, for excluding an argument from the component, from the components report, or how consider syntax for excluding an argument from components set of exposed parts. Really, that's what it is. In the end, the report says what the parts of the thing are, and look ahead right now probably will show up there, even though like we only are going to use it for internal logic. Right, so graphic control block. That's like a smaller subset of what we just did, right? It's really just that we're distinguishing between that it's either a graphic control extension or it's not, right? If it's a graphic control extension, parse it. If it's not, then we have to go into another syntax that it called the graphic rendering block. Okay. Graphic control extension was the first line here. So that's this, right? So if it's that, then, oh, there is no else, right? Because what is this? There's an optional graphic control extension, but we always have a graphic rendering block. So graphic control extension. And then we have a graphic control block. Graphic control block was one of two things, right? Right, so again, there we're gonna have, it's gonna want to have the access to the look ahead. Okay. Graphic control block. I mean, graphic rendering block. Is that what I wrote? No, I wrote it control rendering block. Graphic rendering block could be one of two things. So yeah, that's where the other two ifs branch into. So that's these two right here. If it's that, it's one thing. Otherwise, it's the other thing. So table-based image or plain text extension, right? Table-based image. Or plain text extension. I should probably just close some of these things I haven't been looking at very much. And then they won't be in my way and I can just easily click them, right? I've been using the grammar, so I'll keep that one open. So now, and then maybe I should just drag this over to here so that they're next to each other. Sometimes I neglect doing that kind of thing. Okay, table-based image. Yeah, this is much nicer. Table-based image is an image descriptor, local, and then it may be a local color table, and then image data. It's image descriptor always. And then it's this if part that we were writing before, right? I'll steal it from the global color table thing here. Let me just copy this, right? Because it's very similar. So we're going to have like a flag. It's called local color table flag. Actually, you know what? I remembered I don't need to do this. I can actually peek in after parsing. So I don't actually need to do that. I can just say if that dot that, if that dot that, and that dot that, and then that dot that. And then I don't need any of that. So we can say parse logical screen descriptor, and then we can peek into it to look at the flag and the size. So I can do a similar thing for the other thingamajiggy. Local table-based image, right? We don't need a flag. It's just, there's an image descriptor, right? And then we just say if the image descriptors dot local color table flag. It's actually, yeah. This goes there. Actually, it's not global color table, it's just color table. Oh, actually, no, they have different names. They got different names, so it's local color table. Okay, so then what's the third thing? It was image data. Okay. So yeah, it turns out I didn't need any of this, right? Okay, okay. Special purpose block, I don't have, right? It's either an application extension. Okay, so we do need to look ahead. Okay, so a special purpose block is either application extension or comment extension. Hey there, Scott B1969. Application extension has a label of FF, comment, so it's either FE or FF then, right? So it's the second byte we really care about. Actually, we should just, no, we only need to look at the second byte. The actual extension will confirm that, will reparse and confirm that the first byte is correct. So this would be that if it's FF, it has to be an application extension. Otherwise, it's the other thing. Application extensione. Otherwise, comment extension. Right? Okay. Right, this thing, right? So the we don't need unknown extension anymore because there are no unknown extensions. Right? So this was comment extension. And this is the comment extension label, which is FE. This is not Rust. This isn't even C++. This is my own domain-specific language. In the subsequent streams, when I get to it, I'm going to be making the compiler for this language in Rust. But right now, it's true that the compiler for this currently is in a combination of C and C++. C for the lexer and the parser, the compiler part, and in C++ for the parser part. Yeah, is it public? Nope, sorry. I'm not actually allowed to contribute to open source right now in the job I have. 3 conditions of well, 3 relevant conditions that in the job that I have right now. I can't contribute to open source without permission. When I stream, I can't do game dev, and I can't talk about work. So yeah, that's if I don't like that, then I gotta find another job. Okay, so did I get everything here, and did I put it in the right order? So a GIF is a header, logical screen, data, and a trailer, right? Header, logical screen, and then this is data and a trailer. Okay, that's correct. Logical screen is a logical screen descriptor and a global color table. Logical screen descriptor, global color table. Got it. Data is a graphic block or special purpose block. Oh, we haven't done that one yet, right? That's data. Oh, no, we did. It's a graphic control block or a special purpose block, and that's how we determine which path to take. Graphic control block is a graphic control extension, maybe, and then a rendering block. Okay. Rendering block is a table-based image or a plain text extension. Table-based image or a plain text extension. Right. So table-based image is an image descriptor, possibly a local color table, and then an image data. That looks right. Special purpose block should be next. It's either explication extension or a comment extension. That's good. Okay. So then did I ever use extension label? No, so we can delete that. Okay, and this we don't need because that's the very next statement. And this I just had there for reference, right? Oh, and don't I need to return something here? Oh, no, I was not going to have it return anymore. We're going to peek into the image descriptor to get these 2 things out. So you work for an undisclosed game company. Can't talk about it. That's one of those 3 rules. Yeah, they actually said I can work on games, but I can only work on games by myself at home for presumably my family alone. I can't share it with anyone else. It was sort of weird. But I did get permission to stream educational content, like Advent of Code and like, doing Rust coding. And this project I'm doing now, it'll eventually be Rust, but right now I'm just getting things resurrected. This parser that you see the output of here, like I said, it's in C and C++, and it's several years old, and the last 5 streams has just been like making sure I understand how it works and fixing any bugs, and then we'll port it to Rust. And that's what I specifically got permission to do. Okay, we don't need data blocks anymore, right? That was an early oh, we do still have data blocks. Okay, but we don't have that filled in yet. But I think that's okay because we have it in a bounded region. Data block was here, right? Oh no, that's here. Oh, I think image data ends up taking... Wait, where do we actually reference data blocks? We do at the bottom of application extension? Really? Was that just generic? Like the application extension can have any kind of data blocks? Application extension. Oh, yeah, data subblocks. Application data. Right, set application identifier, application. So it's not really data blocks, is it? It's data subblocks. It's data subblocks. Data blocks. Do I want to say sub blocks? I think I do. Be consistent, right? Okay. All right, then what was after that? Trailer, and then yeah, okay, so that stuff's fine. Should I see if I missed anything? Let's run it and see what I get. Do I get actually all the way down to the end of the file this time? No. It stopped at the end of logical screen descriptor, so I must have screwed up. Unknown format data look ahead. Oh, okay, I never wrote that. I forgot to write that. Let's write it. That was near the top, right? Yeah, this thing. I never wrote that. So it's supposed to give me the first and second bytes, right? So let's put it down here somewhere. Data look ahead. Actually, it doesn't need to have look ahead in the name, right? Because the plus after it means it is a look ahead. So really this should just be like data first 2 bytes or something. Data header. Let's call it data header. Data header. Yeah. Okay. Data header. So data header is a UI unsigned integer of it was like first and second, right? Second. That's all it is, because then we reference it in the reference it later in the parser. Okay. Still bad. Look ahead first unfound. Look ahead first unfound. Oh, that's not good. That's not good. Let's do a full debugging. See what we get here. Okay, here we go. So decompose data, local look ahead, data header, decompose data header, look at the first, and there's there's 2 log messages mixed together. So skipping here. So we get 33 for the first, and we get 255 for the second. Oh, that's right. Don't I have to like return the thing? Oh, no, I shouldn't have to return it. I should be able to look into it. Yeah, why isn't it letting me do that? Why is it saying it's unfound? Is it because it's doing a copy? Let me test that theory. So my theory is that it doesn't like, where are we? In data, it doesn't look that I am doing a copy. But what if instead of it being a local, we just called it look ahead? So we don't ignore it. We call it look ahead. Like that. Now will it work? If so, then I think that means I need to fix something. Error, look ahead second unfound. So it got the first but not the second? Yeah. Second unfound. But it got the first one. Well, that's weird. Oh no, here's the second. I think just my messages are scrambled again. I think if in my code I turned off standard output and standard error buffering, this wouldn't happen. I should probably go do that, right? Is it like set buff to null or something like that? Data header second. Oh, here's the problem. Nil. Nil is being assigned to it. That's just the overall value. That the dot syntax should still work. Yeah, so that worked, right? It referenced it. Okay, I think I know what's going on. It was able to use it locally, but when it passed it to special purpose block, it had a problem, right? Special purpose block couldn't use the look ahead. Okay, okay, so then we do have a bug. So we were able to peek into look ahead at the first and second because it's a part, but then when we pass it as an argument, we're we're only taking the topmost value. That's the problem. I want to be able to pass the whole part in. I don't think I support that right now. The parameters are just values. So what does that mean? The value, it needs to convert it into like a map, right? If I remember right. Um, so yeah, let's put this back the way it was. And let's have the data header actually return a map. So like return, it's just I don't remember the syntax for this. I guess I'll have to look it up. What's map? Key value mapping. So a key value is some expression colon some other expression. Okay, that's not ideal. That's probably for literal maps, but how do I make like map is a reserved word, I thought. That's a literal map, right? Yeah, key values. Map construction, I think this is where if we have the reserved word map, left parentheses, reference to the keys, comma, reference to the values. How does that work? Keys and values. Map construction. How did that work? I'm gonna peek off stream. See how this worked before. Can't show this stuff, right? I can't show this part of it, but we'll get. You're not missing much. Vector. Hold on. Ew. Okay, so if I'm reading this correctly, I can just do something like this. I can say return map. First, second, first, second, like that. And now it'll become a key value lookup that I can use. I have no idea if this is going to work. Let's see. Syntax error. On line 194, column 16. Can't see the columns because it's in the way. 16. So right here, that's a syntax error. Okay, I don't know how do you do a literal vector? Literal vector, here we go. Oh, left bracket. Okay. Expression list. Optional comma. Okay, so I need to have brackets. Bracket. Still a syntax error. Really, it doesn't like the bracket there. Is that because that map, it has to be a reference to the keys? Okay, so then what? So this is really constrained, isn't this? Is really contrived. That means I have to make a local called keys, and then a local called values, right? Can I have an assignment as part of local? No, it's just declaration only. So yeah, I have to say like keys, and then I can do an assignment. I think I can assign the literal value to it. Yeah, this is really contrived. I think I should probably work on this one, right? Okay, that should be proper syntax. No, it still doesn't like it. It doesn't like on column 20. It doesn't like that comma. Right? It doesn't like the comma there. What's wrong with the comma? What is wrong with the comma? So that's literal vector, right? Literal vector. Left bracket expression list. Well, that should work. Wait, maybe the problem is I can't have... This is in the context of an expression, right? So can I do an assignment statement? Conditional logic, for loop, while loop, bounded region, assignment. Something equals expression semicolon. That's what I'm doing. Something equals, this is an expression. It's a literal vector. Unless I'm not understanding. Did I get braces and brackets confused? I bet I did. I bet I got them confused. Bracket, not brace. Bracket. There we go. Does that mean, is there a literal map? A literal set, but do I have a literal map? Oh, I do have a literal map. Key values. Okay, then why don't I just... Okay, well, let's see if this works. This works, I can try the literal map. Okay, that actually worked. It worked for a while, and then it stopped. Where's the error here? Unfound. Probably because I didn't return it correctly. First, second, values. I actually don't see how it's... Yeah, here's the values, here's the keys. Where did it actually save it? I think that's the problem. It didn't. I didn't do that part. So that's under at line 10. That's not right. It's not line 10. This 77 to 85, right? 77 to 85. Hello, friend Yuckins. How are you doing? Mr. Balrog, why do archaeologists get the most girls? Because they have the best dating techniques. Ba-dumpt. 77. Okay, so it's when we're using this, right? So, this store still didn't work. So this local, probably because, is it because it's an ignore? The copy should have still worked. Did maybe data header isn't returning? No, we're returning it. Okay, so then what happened here? Why did it not get copied? I thought I wrote that yesterday. It should have copied the value. Why can't it find it? Oh, because it's not using map. Map uses an index operator, right? Okay, yeah, I think I'm going down the wholly the wrong path, right? Um, it's gonna look weird the way the syntax currently works. So it's gonna have to be back here, and it's gonna have to look like this. Instead of look ahead dot. How do I select all again? I thought it was oh, there we go. Instead of look ahead dot, it's look ahead index. With a string. All right, it looks awful, but I think that's all I can do for now. No, it still didn't like it. Look ahead for it still can't find it. Well, that's depressing. Okay, I'm gonna fix the problem that my error messages are mixed in with my standard output. I think the right way to do that is in the main program for this, which was the decompose. In the main, I think we just turn off output buffering at the very top of main. I thought that it's like set buff, right? Standard out null. If I remember right. And standard error usually doesn't have buffering at all, so I don't need to worry about that one. We'll turn off standard output buffering. I think that's how I fixed that problem, so build it, and they will come. Terminal, and then run it. Hopefully now it should be mixed properly. Yeah, so now the error, which is this :10, level 10, right, is in the correct position relative to the output, so it's easier to read. Should have done that like 25 minutes ago. Okay, so the data header, which I guess that's what this means, that it is a map. It's storing it in look ahead, but then it can't find it. Okay, we don't need that anymore. Okay, yeah. It's supposed to return it, so it should be the value of data header. I'm wondering if it is because I'm doing an ignore. Maybe I don't ignore it. And maybe that fixes it. No, it still can't find it. It's unfound. Maybe the copy didn't work. So instead of doing look ahead, we'll call it data head. So let's get rid of the, not get rid of, let's comment out the local and replace look ahead here with data. Actually, you know what? It's better. Let's just call this look ahead, like that. Still can't find it. Man, is this not the right syntax for doing a dereference of a map? Maybe it is the dot syntax after all. Okay. Dot like that. No, it still can't find it. Unfound. Okay, I'm getting frustrated. I want to know at least how it works. Can I just print it maybe? Can I like, let's do an error and just say like, look ahead looks like this. Plus look ahead. Can I do that? Can I add a map and have it print it? Enable promote operand that and empty map. Okay, I think the problem is the map is empty. It should have printed something, right? So like, what if I put an error down in here? What if I say an error there? It's empty. So the map is not constructing this correctly. So remember something you've written? What do you mean? Is FMT something you've written? I've written all of this. It's the problem is I wrote it like 4 or 5 years ago and I forget what I did. It's concerning to me that I get an empty braces here. Let me just look how this actually supposed to work. So that's in like where is it? Is it in decomposition or is it in? I think it is in decomposition. This shouldn't be here, by the way. Anyway, decomposition, bitstream, value. Here we go, value map. Let's see how value map is supposed to print itself. Render, right? So we're not seeing anything. We're just seeing empty braces. So that means that there is no set of values. There's no key values in it for some reason. But what is the language for? Okay, then I'll give another stream intro because you missed the beginning of the stream. So I made a tool that, given like a description of some kind of binary format, and I picked a format that almost everyone is aware of, knows what it's used for, GIF, right? It's to make something like this, but in actuality, to a computer, it looks like this. And so I'm writing a tool that if you can describe what these bytes mean, so if I say, well, those bytes mean this, then it will take this description, which is written in a language that I created. It parses, basically compiles this into an abstract syntax tree and then uses that to parse this. And it will output stuff like, well, if I show it in a more user-friendly way, right? It looks like this. It's like, oh, look, we see that this first 3 bytes is the signature in the header, and then the next 3 bytes is the version number. And then we have a logical screen description that says the logical screen width is 300 pixels, right? That's that right there. So it's a generic binary data parser or data analysis tool. A similar thing to this would be like if you've ever seen the tool called Wireshark. Wireshark image search, and like I just pick one of these images. See this down here where it shows you the raw data of some kind of packet, and then this window here kind of interprets what that data means. I'm doing a similar thing. So somewhere in Wireshark or in a plugin to Wireshark, there's like a protocol analyzer that takes in these raw bytes and then like kind of lists out what each thing means. And you could actually click on these things and it'll highlight the exact bytes that correspond to the hardware size. Like it's in there somewhere. It's probably this byte here, this 6, and this byte right here, 4, is the protocol size, right? and then the protocol type 0800 is probably these 2 bytes, right? So I kind of want to make a similar thing, only very generic, not just network protocols, but like any kind of binary data. And I didn't want the tool to be locked to any specific format, so I wanted the format to be something you could specify yourself in something that kind of looks like a cross between functional programming and structure definition. So like this defines the structure of a GIF file, and it also in how it defines the structure, it uses like code flow semantics like loops and conditionals and stuff like that. About to ask if it's just binary, or you answered it. Could you say could do PDF? Well, if you open up a PDF as raw data, it's also just bytes, right? I have built-in types for like S is for string. So if it's string-based data, you can just, the parser can just say, okay, the next so number of bits is a string, right? So the way I designed it is you build up constructs. So like a header is further elaborated here, right? And like logical screen is down here, and a logical screen has its own pieces. So it's like a data tree in the end. So you could do something similar with the PDF. You could say, well, overall the PDF is all of the bytes, but if like maybe the first 100 bytes of the PDF is like one part of the PDF, and it means this. This works better the more specifically structured data is. If you wanted to parse a generic text file, it would be a lot harder to describe that, because a generic text file, the only thing you can say about it is that there are lines, and that the lines are each a string that ends in a new line, or character return line feed, right? That's all you can really say about that. And then the meaning of the strings, like whether or not it's a poem or a short story or a news article, that would be very hard for a parser to tell you, because that goes beyond just what do the bytes stand for. That's more of like processing the actual data within the context of like a language, or like extracting meaning from that. And that's like something more in the realm of like what ChatGPT would do. So I'm not going that far. I'm not trying to make it intelligent. It's mostly just interpreting literally what the purpose of each byte in the format means. So like, for example, it doesn't have any judgment or extrapolate the meaning for this signature. It just says, is it literally GIF? If not, it's an error. Otherwise, it just is what it is. And then it's up to you to like extract like the fact that it's an image. Like this parser doesn't know it's an image. And I could have the parser figure out what every pixel means, but it could never show you the lull slide. It can't do that, because that would require like not only figuring out what the pixel colors are, but then knowing what to do with that data after it figures out what it means. You know, like arranging it on the screen and drawing it with like in a certain way. That's not something we can do here. So it kind of like this is to build up a tool that like a human would use to like kind of like a microscope to peek into a file and like see what's wrong with it or what it means. But then once you've looked at it with the tool, then that's all the tool can do. What you want to do with what you see is outside the scope of this project. Like, in other words, like if I want to make a program that draws GIF images, this tool won't do all of it. It'll maybe extract the color table and the pixels, but then that's it. It's up to me then to like write something else which takes those pixels and colors and actually draws them. But this even though it doesn't like do everything, it does quite a bit. Like if I had like a bad image file, like a bad JPEG, and I want to see, well, why is it bad? Why doesn't it load in my browser? I could tell the parser just completely decompose it into all of its fields, and then wherever it hits a parse error, I would say, oh, well, there's damage to the file, or something's missing, or something doesn't match this JPEG specification. And then maybe I'd be able to repair it if I saw it was a single byte that was like erased. I could like restore it to what it should have been and maybe repair the JPEG that way. Not that I would use the tool for that. This is mostly just like The tool, I I intend to use this tool for like whenever I'm debugging code that works on binary data. Like if I'm making a game and a game has save game files and the save game files are binary, they're not human readable. I would want to have a tool like this that can like show me what's in the save game file and show me where where my character's equipment is stored inside the save game file, or where like the quantity of the number of gold pieces my characters have is stored, and then maybe I would um, you know use it to detect bugs in how the game is saving the saving the game files. All right, I've done enough ranting. I was trying to figure out why this isn't working. Maybe it's in this map construction. Maybe let's just look at that code a little bit more closely. This creates an expression and it just stores keys and values, and those are references. Oh, wait, that's the problem. Because those are local values, local variables, and they get destroyed, right? Don't want to disturb the code flow too much. Yeah, well, that's my own fault. I get off on tangents based off of chat, which is both a good and a bad thing. Okay, yeah, so the problem is I can't use the map construction because it stores references directly. And yeah. These are references, sure, but they are these are references, but they're also locals and they get destroyed at the end. So these references cease to exist, right? That's why we're ending up getting an empty map right away. Okay, well, is there a syntax I can use? Like, what about literal map? What about keys values? Can I use that? Keys values. Keys values. Where are you? Here we go. Key value. What's a key value? Okay, maybe we use because we can use expressions, which are values. Okay, so then if I use the literal map syntax, way down here somewhere, literal map, right? It uses keys values, which are expressions, whereas these are references. I need to come back here, I think, and reevaluate this because this was counterintuitive to me. Probably I made this for a specific reason that no longer applies. Let me make a to-do. So consider redesigning map construction. Right now it works with references, not values. And that's a problem if you use local references and try to return them. If it was the Rust compiler, it would have said that I have a lifetime issue, right? Because local reference, we're just putting the references in a map, and then instead of error, it was returning them, right? Then we're returning local variables. That's not a good thing. Yeah, exactly. Is it a lifetime error you smell? It is. So let's try to use the literal syntax. That was braces, right? Brace. Key values, right brace. Key values, so that's that's literally like first, second. What I want to see is an error message that actually has the actual parsed values in it. There we go. We did it. We did it, chat. So Instead of error, we'll do return, and we're getting rid of these locals. And then that goes up to data header up here, right? Yeah. So let's try to do what I originally wanted, which was that this doesn't have this is discarded, and we store it into a local. Let's keep the error in there because I want to see the error at the end. Yeah, there we go. So even though we can't actually add for in an error message, it still at least prints it in the meta error message. So I know that it's there. So we should. Now the problem is this how we dereference a map, or do you use the dot syntax? I don't remember. Actually, it got a lot further, so it must have worked, right? Yeah, it actually parsed out the application extension. Cool. So that means it got in and all the way down into application extension. Right? It got all the way down into here. And it told me again that the secret Netscape code is 3288624. So there's no error. Oh, there was an error. Unable to fully decompose file because we're skipping bits. Where are we skipping bits? Unknown format graphic control extension. Okay, so that's a problem. Graphic control extension. Did I forget that one? It looks like I did. Yep, I have rendering block, but I don't have control extension. Graphic control extension. Okay, so back to here we go. Let's find graphic control extension. Graphic control extension, where are you? Graphic control extension. All right. That deserves a bookmark, right? The graphic control label is what it starts with. So what's another extension I can steal from? Like this? Let's steal all of it and paste it here. Okay, so what do they call it? Again, extension introducer, right? Which is always 21, right? It's always 21. And then the graphic control label is F9. F9 is graphic control label. Okay. And if it's not F9, it's a bad graphic control label. Okay, now what comes after the graphic control label? Then we have a block size, packed fields, delay time. The block size is a fixed thing, I guess. Fixed value of 4. So it's 4 bad block size for graphic control extension. Okay, so we have some packed fields. Let's specify them, all right? So we got some reserved bits, so I like to just say that like that there, and then we ignore them. Reserved. Reserved. Okay, and then we have a disposal method. Disposal method. 3 bits. And then we have a user input flag. Bit. But flag. And then we have a transparent color flag. Okay, that's it for packed fields. 3, 6, 8, 9. What's next? Then we have delay time unsigned, and then transparent color. So delay time. Little endian UI, right? 16. Delay time. And then transparent color index is a byte. Transparent color index. And then a block terminator. with no data subblocks, right? So I will just look at data subblocks to see how they define that. We don't actually have a syntax for that. Let's make one. Block terminator, right? So block terminator is defined as it's just a byte that has to be 0 or something. A 0 length data block marks the end. Actually, maybe I would just say, well, it's sort of coded in here. So it's just a size. And then the size has to be 0. And then it would be bad block terminator. Terminator. Okay. So then block terminator goes at the end of this. Cool. So that's our graphic control extension. Let's see how our parsing goes now. Unknown format plain text extension. So here's the graphic control extension, right? So we have block size 4, disposal method 3, no user input flag, transparent color flag is 1, delay time is 3, transparent color index, terminator. Does that mean we're getting the, okay, no, it's, so there's a global color table, then the application extension. Oh, we have a problem here, right? Oh, right, we're skipping it on purpose because we don't know how to interpret that data block. And that's an appropriate warning, right? We're skipping data we don't understand. Yeah, okay. And yeah, then the graphic control extension. So yeah, any plain text extension. Plain text, whoops. The copy didn't work. That's because it's from the terminal, right? It's Control-Shift-C, which is bizarre to me. Okay, yeah. I guess that should go after table-based image, right? Okay, what's a plain text extension? Plain text. Here we go, plain text extension. Actually, what is this? Contains textual data and the parameters necessary to render that data as a graphic in a simple form. So lol slide has a plain text in it? Interesting. I wonder what kind of secret text we're gonna find. Because when we look at it, I don't see any text here, do you? Do you guys see any text? There's no text here. Apparently there's something in there, and we're gonna figure out what it is. So I'm gonna copy from graphic control block because it kind of starts the way I want it to and it ends the way I want it to. So plain text extension has a extension introducer, then it's plain text label. Bad plain text label. And what's that label have to be? It has to be 1. All right, and then we have block size, which has to be 12. Bad block size for plain text extension. Okay. Then we got text grid left position, text grid top position. So we don't have any of these. Let's just leave them, keep them for now. Text grid left. Can I cheat and just like copy that and paste that and then take all of these spaces and turn them into underscores and then Can I go over the whole thing and go like lowercase? Look at that. That's awesome. And then the next one is just top, right? And then it's width and height. Oh, and these are unsigned little endian. Little endian, unsigned integer 16s. Okay. And this was text grid width height, right? Height. And these all go away. Okay, and then what's the next? Character cell width height. Okay, what's next? Text foreground color index. Too much typing, too lazy to do it. UI paste, and again, it's take the spaces, turn them into underscores, take the whole thing and lowercase it, and then it's 8. Done. And then same thing, but for background instead of foreground. So back. Okay, and then we get data subblocks for plain text data, and then so then we had a syntax for this, right? It was data blocks, data subblocks, just like for application extension. Right here. Okay, let's see if we get further in the parsings. Bad extension introducer. Ooh, that's not good. Got a 44? $21. Wait. 44, not 33? So does that mean I have a bug in the graphic rendering block? I think that is, I have a bug here somewhere in graphic control extension. Well, the terminator's correct. Wait, does that mean we parsed the, wait, did I mess something up? Because, like, I thought we were seeing that it was a text thing. Yeah, plain text extension. Right, okay, yeah. How did we get here? I'm confused. Go back to the format. Oh, because it didn't match a table-based image? Really? We're in graphic block, right? We matched graphic control extension, and that following that's supposed to be either a table-based image or a plain text extension. Oh, are we not matching on... It doesn't look like a table-based image? It doesn't look like an image descriptor? What's image descriptor again? Image descriptor has to begin with 2C. Is that the problem? That might be the problem. So let's see. Graphic control block. That's the problem. See, it uses the look ahead, but we've already, so we need to like recompute the look ahead, right? So we need to look ahead again after this. Actually, the real solution is that no, we have to recompute the look ahead. We need to do this again. Actually, it doesn't need to be declared local. We just need to do that. There's another data header, and we need to update look ahead. That's the problem. I don't like that my hat thing goes away. It's like it's not doing it though. It's still seeing the 44, right? Bad extension introducer. What was 44 again? I'm getting kind of lost. Oh, it's an image descriptor. So it should not have matched graphic rendering block. It shouldn't have gone... Wait, table-based image. It shouldn't have gone into plain text extension. Why did it go into plain text extension? It shouldn't have done that. Why did it do that? Oh, because its look ahead's not right? Okay, do we need to like actually error out on this to see what it looks like? First is 44 seconds 0. That's correct. What does it look like down here? Yeah, that's correct. 44 and 0, right? It's an image descriptor. How about we go into graphic rendering block? What does it look like there? 44 and 0. So it should have gone into table-based image, not plain. So why did it go into here? It should hit here, right? It does not. Why not? Oh, it's this 1. It's actually a 0, not a 1. Okay. Why did I think it would be a 1? Yeah, that's not right. I think I got that confused with that. Right? 21 followed by 1 is... That's plain text extension. Yeah, I think I got them flipped. Plain text extension. $21. Yeah, okay, I got them backwards. That goes there. Actually, so then the better way to do this would be, because the syntax arranges it the other way, is to just check if it's an image descriptor. And that's easy, right? Image descriptor has a label of 2C. And that's the second byte though, right? Image descriptor. Oh, I get lost in all these things. Yeah, it's got a field separator of 2C. That's the first byte only. 2C. Is that what it said down here? Yes. So the first byte is 2C. So yeah, it would just be easier to do this. If look ahead first is 2C, then it's a table-based image. There we go. Okay, so I can get rid of that error that I have in table-based image. Actually, I don't see the error. Oh, it's right here. Okay. Unknown format image data. Okay, so we got further. So we got the image data. What's image data look like? It's data subblocks. So we can just say image data, data subblocks. Oh, it's the other way around. The data subblocks is image data format. No, the format's data subblocks, and that constitutes the image data. Bad extension introducer. Okay, so we got further. We got all the way down to 186F. Oh, we have extra. We're skipping all the actual compressed image data right now, which is fine. So what happened here? It thinks it's seeing a comment extension, but it says that there's a bad extension introducer. I need more debugging. It sees a 9 byte for some reason. Oh, is it because of the look ahead? It sees a 9 followed by a 3. That's weird. That's not right. It sees a 9. After the image data. Because we saw a Terminator. A Terminator. At 186E. So 186F is the next byte, right? 186F is a 9. That's not correct. Okay, so I guess we're misparsing the image data. Yeah, there's just a lot. What is it? 30, 40, 48 image data blocks. So we're probably getting all confused in there. I don't think these are right. I don't think you'd have such small blocks, right? Oh, wait. We missed the local color table. We're supposed to have one there. Yeah, that's it. So the table-based image, we skipped the local color table. Ah, so much work to do. Yeah, we skipped that. I skipped it by accident. So table-based image, it was supposed to do that. Why didn't it do that? Was the image descriptor not... Was the flag not set in there? Oh, the flag is 0. Is this right? That can't be right. 11,265 for the image width? This might be not being parsed correctly, right? Is that lol graphic actually 11,000 pixels wide? What does my file system say? Open folder, projects, DataDisintegrator stage, loljif. Can I look at properties? Image, it's 300 by 300, right? So we shouldn't get 11,265. So that means that we didn't parse this right. Okay, I know we're parsing correctly the application extension because we see the word Netscape. We're getting the right code for the graphic control extension. Block size of 4. Wait, that's not right. One, 2, 3, 4, 5. What? I think I messed up in the I messed up this one. Graphic control extension, right? Okay, compare that to what do we have in the spec? Plain text, comment, graphic control extension. And I even had a bookmark I could have used. One, two, three, 4. Size 4. 1, 2, 3, 4, and then a block terminator. Actually, that looks good then. Then what did I do wrong? How did I think I saw? I thought I saw 5 here, but I guess I'm wrong. 3, 4, 5, 6, and then 7 is the term. Okay, yeah, that's correct. So then this is the first byte of the next part, which is right. It's an image descriptor, table-based image descriptor. So did I get image descriptor wrong then? Image descriptor. Right, so it's 2C and then left top width height. Left. Oh, this is all wrong. These all little endian, right? Little endian 16. Like that. That's why I was confused. Because the width and height should be correct there. Yeah, okay, here, 300 by 300, right? Okay, so that's correct. The flag says is 0. I need to double check if does 0 mean there is no local color table flag. But then there is a local color table size of 2. So that maybe I'm misinterpreting that flag. And then it goes directly into the image data. But that block is suspiciously low because I would imagine that all the blocks would be maximum size because otherwise you have wasted space for the size fields. So I'm guessing that that's actually a color table value and then I'm misinterpreting that flag. So back to the spec we go. How do we interpret local color table flag? Indicates the presence of a local color table flag, meaning this field is the most significant bit of the byte. Or is that how we're interpreting it? The most significant bit? Yes. .1, right? Most significant bit. We're seeing all of that byte is 0. Then why do I say 2 there? I don't get that. Oh, because it's 2 to the power of that plus 1, which is 2 to the power of 0 plus 1 is 2 to the 1, which is 2. Okay. But we're supposed to ignore it because this flag is off. There's something wrong here. something I'm missing. Did I get the 2 reserved bits, by the way? It did. Okay, what? Okay, if there is no local color table, what's immediately following the local color table? Local color table, image data. Maybe image data has a header that I didn't consider. Let's look for image data. Oh, it's LZW compressed. Maybe that's the problem. It's actually substream. I think that might be it though. Table-based image data. The image data for table-based image consists of a sequence of subblocks of size at most 255 containing an index into the color table. Blah, blah, blah. The sequence of indices is... okay, so that's inside the blocks. It's encoded as LZW, right? Oh, no. We forgot. We have a LZW minimum code size and then the data blocks. Okay, that's the problem. So, image data, where are you? It's not... where are you? It's not data subblocks. It's actually just image data. Oh, well, it sort of is. But we need to have an image data here, which has a data subblocks in it. But before the data subblocks, we have an LZW minimum code size, which I'm not going to type. This is image. Well, this is... I can't use the same name, but they use the same name, right? We'll just say data subblocks and not give it a name. UI that 8. Okay, so let's get rid of the spaces. They are underscores. Take the whole thing and lowercase it. Okay, now do I parse it correctly? Unknown format, local color table. Wait, so there is a local color table? Oh, there's more than one block? So we got through the first one then. Oh, sweet. Look at that. We're all getting what I expected. Maximum size blocks until the last one, right? Which is going to be smaller than maximum size. 38. Cool. So that means there were 67 data blocks for the image. It's gone 9. You won't be late for another meeting, will you? Thank you for having me check. My meeting's at 10:35. So I got more time today. Although part of me thinks I should spend some of that time sleeping because I haven't been sleeping very much. Okay, so there's the missing thing. That 8 was a minimum code size. Okay, cool. So we got past the first image. Then we're going to the second image and getting a problem there. So the first image didn't have a local color table, but the second one does. Is that the problem? And I didn't define what local color table is yet. That's what it is, right? So then, local color table. Local color table, here we go. Okay, so it's exactly the same thing as a global color table. I think it is. So we can just leverage the same data type. Maybe we just call this one color table. Yeah, so we'll call it color table. Color table, global color table. So this is just a color table of a certain size. And then where we have local color table, again, we just say color table in front. Okay, run. Ooh, I think we completely parsed the file. Decomposition complete, all bits consumed. So we had 60 frames, I guess. Is there a way I can like do we want to update this stuff now? I'll update that later. Is there a way from the file thing we can actually see how many frames are in that? Projects. DataDisintegrator stage. Here's my little GIF. It just says that it's 300 by 300 and it's a GIF. It doesn't say how many frames are in it. Already my parser is better than this. I think what I'm seeing here is that we have 60 images. Right? So let's get a report now instead of a data dump. Okay, so I'm looking at the data report. We got a lot of stuff in here. Yeah, we're skipping all of the actual data bits. We're not doing anything with them. It's gonna be 60 of them, at least. 60 times 200, it's gonna be a lot, actually. Can I just dump that to a file? Let's dump it to a file in the staging area. Yeah, and then we can look at it. Out. There we go. See, this is where it would be handy to have a GUI, so I could be able to like collapse these sections. A 1 second loop at 60 FPS sounds reasonable. Yeah, it kind of does, right? Yeah, this is what I wanted to remove. I don't want it to just like show up there. So the report basically remembers the bit index of the beginning and ending of everything it parsed. Right, so it remembers that, like if we look for header, it remembers that the header starts at the very first bit and goes 48 bits, right? And then it had this signature in this version. You can, this is what I like about it is that you can like have it say where in the file is the first logical screen description. It's at bit 48, right? Or if I wanted to look for like width, the logical screen width is at bit 48 also, and then there's image widths for every image, right? And here are their offsets and bit offsets in the file. So that's cool. So that means with a GIF, every frame can have a different size. Hey, there's C17R. We just successfully parsed the overall structure of a GIF, a GIF. Oh, cool. I'm getting pinged from work and my coworkers are actually figuring things out. That's always a nice thing, right? So I sort of remember people crafting GIFs where like every frame had a different size and they did funny things in Discord. Do you guys remember that? Like there were these Discord images that would like change in size over time. I'm streaming a little bit late. I don't have a 9 o'clock meeting today. So we got 60 images here. Yeah, I don't want these look aheads to show up there. I need to like modify the decomposer to be able to like, or the syntax for it to be able to mark that I don't want to store that in. That was just a local thing. So each image actually has a local color table. That's kind of interesting. I wonder why they have this file would probably be a lot smaller if they just use one global color table, right? Because all it really is it's the guy scrolling. So why do they have to have a different color table for every image? We could make a better lol slide if we just had one global color table. Which Linux distro? Is that XFCE? There's the OS command. My bot will tell you that it is Xubuntu. Running XFCE, that's what the X stands for. Did I close the report? It looks like I did. Yeah, if I could collapse this, it'd be a lot easier to read, right? It's just like a lot of stuff, and it's like maybe some interesting things buried in there. We'd have to search for it. Like, if I go to the very top, right, and search, is there like any kind of text or right here, the application extension Netscape, that was a really cool one that we found. I don't think that there was any other text, right? Yeah, there's no actual text extensions. We thought that there was one, but I was misparsing it. There's no comment extension, right? There's no comments inside lol slide. No comment extensions. Nothing interesting like that. Oh, how fast that lol slide slides is something, right? That's like delay time. So 3. It's always 3. What does that tell me? What would 3 mean? I guess I should look at the spec and what they say for delay. Delay time. It's the number of hundredths of a second to wait before returning with the processing the stream. So it'll be 3/100ths of a second. So it's not 60 frames per second then, right? It's 100 divided by 3 frames per second. What's 100 divided by 3? $100 divided by 3 is 33.33333333333333333333. That's the frame rate of this. So there are 60 images being shown at 33.333 frames per second. Cool. Okay, I'm happy. I got all the parsing done. Hey there, buffer 0xAA55. I got my parser to get all the way to the end of a GIF file. We can see that if I do it this way. All the way to the end. And it only takes 1.18 seconds in debug mode. So if I don't do the less, right? Yeah, it's like 1.4 seconds. What if I build the release build? Let's see it run faster. Granted, it's in a virtual machine, but it should be faster with the release build, right? It's a little bit faster, but it also might be because we're catting to the terminal. So what if I do, where did it go? It should be like pipe to, well, let's just do no debugging and see. Report, I guess. It's too much data. How about debugging level 3? Yeah, 0.31 seconds. How about only, yeah. It's still spitting out all these warnings, so it's actually pretty fast, right? 0.31. Go back to debug and see what that looks like again. It builds pretty quick though. pipe to file then tail. Yeah, I should do that. Don't know why I'm doing it this way. So let's just debug level 3 gives me the time at the end, right? So what if I do that and then say that this is for debug. Oh, and then I have to redirect standard error to it also, right? That didn't work. Oh, that's because that has to be first and then redirect file handle 2 to 1, right? There we go. And then build for release, build. And then the same thing goes to release.txt. Okay, then what do we get? Debug. 0.57 seconds. Release build. 0.21. So it's like more than twice as fast. So it was taking over a second before, probably because it was just generating a lot of output. So these warnings basically are that we are ignoring all of the raw data. We're skipping all of the compressed image data. So every block is like 2040 bits or 255 times 8 bits, and then except for the last one. So the next level of parsing would be to do the Lempel-Ziv decompression, right? The LZW. If we were to like follow this part of the spec and like decode this using a LZW decompression. So they describe that all here. I don't really want to go to that level. I think I want to just call it that we've specified what GIF is, at least the top level of it. Do I have any to-dos in here? I did. So that's just that here's where if we wanted to, we could assemble a second level bit stream to parse in a second pass as LZW encoded data, right? Which is it's just going to be a sequence of color table indices, which look up the colors to draw when you draw the image. Okay, so otherwise I'm done. This is my specification for GIF. Let me do some cleanup on it. Oh, I wanted to look into that look ahead stuff, right? And the fact that we had to make a map at all bothers me. I would have preferred that data header down here just kind of didn't have to, I didn't want to have to do that. I wanted to be able to peek into the composition of data header. The problem is that if we do this assignment, it copies it by value and not by the whole part composition. They're different. So it's only what I return with a return statement. That's what we get back when I use the arrow operator up around here. This arrow operator just takes whatever this returned and saves it there. If we don't return anything, then this thing still has parts in it. It just can't be referenced there. So to be able to reference it, it has to be a value. Therefore, we need to actually return a value. So a better way would be what? That wouldn't it be that I don't use a local and instead can I just reference it directly? Let me see what happens if I referenced it directly. So if I let's just take within this function here, these look aheads, and turn them into data header. and then make it a dot here instead of that. I actually think that might work because this thing is a part, even though it is a look ahead ignore. Oh, I think the problem is it's ignore. I have to remove the ignore. Now I think it would work. Let's see. Too much data, but I think it did work. We got all the way to the end, right? Yeah, so it works. But the problem is in the report. Where's the command line that actually saved the report? There it is. In this report, we're going to have a lot of those look-aheads, right? Or data headers. Exactly. This is going to show up in every image. We'll have a data header. And that's what I wanted to avoid. We have all these data headers, right? Which I don't need. And the problem is if I make that ignore, it doesn't work. It gets an error that it can't find data header anymore. So I kind of want, you know what I want is I want to be able to say that, yeah, treat it like a part, but don't actually keep it around. Like a local part, right? I'm inclined to actually make an ignore, actually put a part into the composition, but then remove it at the end just like it was a local. Hey there, Winter Coding. How's it going? We are done parsing GIFs for now. I'm just looking at how I might, thinking ahead of how I might modify this to be better for me. But yeah, check it out. We're decoding the entire image, so we have all the data blocks. There are 50 or 60 of them. So if I do like search for plus, if I do regular expression and we say it begins with the beginning of the line, literal, 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 then see we have 61 of them. I guess we have 61 frames of the GIF file. I wish I could like say skip to the 61st one. Yeah, we have 61 frames in the GIF, and we're parsing out the delay time, which I looked it up. It's hundredths of a second. So it's 33.3 frames per second. There's 61 frames, and they're all the same size. They're all wherever it says that. Right here, the width 300, height 300. And we're skipping all of the LCW compressed image data because that would be a second pass, right? You do the first pass to collect the data streams, and then the second pass would be you decode those. And then after you decode those, then you'd use them as indices into the color tables to find the colors, and then I guess you draw them on the screen, right? So basically I finished the first pass of a GIF viewer. Before I forget, let me add another terminal to do a send out of the virtual machine so I don't forget to do that. Yeah. Yeah, I wanted to clean this up, but I don't know if I want to clean it up now, but it would be neat if I could use this ignore syntax, but still be able to reference it locally. Thing is, I'm using this ignore syntax for multiple things now. Here, let me show an example of where I like here, when I have reserved bits, I actually don't even want to give it a name. So I withheld the name, and that's why this doesn't even add anything called UI to the composition at all. Which is important because if you have two of them, it's a problem, right? If I called this thing disposal method also, I get an error, which I'll demonstrate. You'll get an error right here. Collision on disposal method, right? So you can't have two things named the same, right? But what if you had some reserved bits somewhere else in the file, right? If I stored the name here, it would say I have a collision on UI. So I purposely don't store the name if it's ignored. But then we had that example of where, right here, where I want to ignore it, as in I want it not to be stored in the composition, but I do need the name to use here. And so I got around it by doing a copy. But when I did a copy, I only get the value, which means that I had to actually return something rather than being able to use the data header's composition. It's like, I think what it is I want a third thing. I want just normal parts. I want ignored like bits, and then I want something that's sort of in between that, where it's like a normal part, but I can use it locally, but after that we discard it. And local is kind of like that, but local is not for parts, local is for values. So, my cat wants in, but the cat is mean to me. See, she's mean to me when I'm streaming, though. If you let her in, she's gonna, like, harass me. She wants food? Okay. Yeah, she promises only to eat the food and not bug me. Realistically, she's gonna eat the food and then bother me. Alright, anyway. I have a cat now, eating in the same room as me. Yeah. I'm scared. I wonder if I should document these, what these are. Probably should, because I'm gonna be unhappy if later I can't remember what, like, F9 means. F9. Graphic control label. So that would mark a graphic control extension. Or 1. Plain text extension, right? Plain text extension. And 2C. Image descriptor. Image descriptor. Okay. And that comment repeats down here. Okay. Actually, now that I think about it, even if I turned this data, the look ahead into a component, when I pass it as a parameter, we can only really look at its value again. I got to think about that. Like, maybe if a value, maybe right now I have values are like numbers, strings, maps, or lists, right? But what if I had a value which is really the same as a part? So you could pass a part as a value. Then you could reference it. And even you can even get interesting things like where is it in the file, right? Yeah, that's something to consider. Let me put that in this. Consider ability to use parts as values. Can't do that right now. We can only use return statements can extract from parts to form new values by copying. Okay, any more comments that I want? Oh, well, that just says it's that, right? Actually, no, it's image descriptor, right? 2C means image descriptor, so I should say that right here. Okay. I think I'm pretty much done for now. I could refine this to actually use block terminator by doing a look ahead, because that's what this is sort of doing. But I don't really feel like it right now. I think I'm going to just say that we're done. So we are done with Kajif. Done. Let me try that again. Done. We are done. Okay, what to-dos do I leave myself? A bunch of stuff to refactor this thing, but maybe, you know, a lot of the stuff can wait until we do it in Rust, right? Maybe that's the next thing that I do. I start trying to make this in Rust. That's going to be a major undertaking that I don't want to start when I only have like 20 minutes left. So, although I guess I could just do start with like doing the Lexer. That might be fun because now we have a format that actually we know works. We can like make a Rust Lexer that just turns this into a token stream. Well, I can delete these files. I don't need them anymore, right? Cut or delete. Move to trash. I didn't know Linux had a trash. Did you guys know that there's a trash in Linux? We keep that around because that's interesting. Although I want to regenerate it one last time. There's the report. Lexer should be fairly quick. That's what I was thinking too. I was gonna use your there was a suggestion for the Lexer, right? Logos. I could at least read about it and maybe start playing around with it, right? I could set up the workspace. I could at least do that. Logos, yes. Let me at least get prepared for that. So if we're going to go to home, we're going to go to libs and we're going to type in logos. Create ridiculously fast Lexers. It's already won me over just with that. Oh, and it's got like a cool little icon. Logos has two goals. Make it easy to create a Lexer so you can focus on more complex problems. Make the generated Lexer faster than anything you'd write by hand. Combines all token definitions in single determinant. So we already have that, right? With Bison, which is fine. So it's just going to be doing it in Rust. Optimizes branches into... Okay, that's cool. Prevents backtracking. Cool. Unwinds loops. Cool. Tells that heavy lifting of compile time. Nice. All right, everything one would expect, right? Skip. Ignore this between. Okay, so we define all of our tokens as an enum, and we can tell it what to skip. So that would correspond to my Lexer, right? And that is, I didn't have it open because we weren't looking at it. Let's look at it. Let's close everything. Close everything. Okay, the Lexer's under formatting here. There's like a default rule, right? Anything, yeah, white space. I think it's the fact that it doesn't actually emit anything. Like comments and white space don't emit anything. They don't have a block. That's how they get ignored. So I guess in our equivalent thing is we would have two things we want to ignore, right? Comments and white space. You had to look at the output of it, and from the looks of it, it generates what looks like a perfect hashes for the string literals. What's a perfect hash for a string literal? Okay, so how do we use it? We make one. That's the input, I guess. I presume that it doesn't have to be a string literal. We can give it an interface to read data later. And okay, next gives us the token, and span tells us what part of the input it came from, and slice lets us view the original text, right? Okay. That's actually pretty nice. I like it. We can do that, right? Can also call arbitrary functions when a pattern's match, which can be used to put data into a variant. And that would kind of match what we're doing with some of this, right? The fact that I'm doing this stuff and like parsing escape codes and junk. Yeah. So that's exactly what they do, right? It's like for a number, if you match that, then you're going to need to call this function to massage it, right? You get the slice and then you parse it again. Yeah, that's cool. A string literal would be fast. Okay. Can handle callbacks with the following return type. What does that mean? Handle callbacks. Oh, the arbitrary function? Right. So kilo and mega can return an option, or it could return nothing, or it could return an error. As long as it's convertible to a logos error. Token as logos error. Token as logos. The left-handed turbofish still confuse me. It's basically saying this is a type, and this is the trait that this type implements. And then so error, I guess, is a type from the trait, but we want the concrete token error. But we have to say we're getting it through the logos trait or something like that, right? That's how I interpret that, but maybe I'm wrong. So there's a special skip type? Why is that linked to librs? Yeah, I think that link's broken. Token would be the enum you're implementing. Yeah, exactly. Logos is the trait the macro implements. Yeah, I know that's a trait. I was looking at how the error works. So I'm guessing error is a type in the trait. If we were to look at that. I don't know, let's look at it. API reference, new tab. And we look at the trait. Where's the trait? Traits. Logos. Exactly. It has the type inside of a trait, right? So where was I looking at it? Yeah, this is saying that take this type token and considering its implementation of logos, find the error type, and then that type, use its from method, consume that error. So it's going to convert it from some other type that's convertible into a logos error. And this picks a concrete type, right? Which we have to do because we need concrete types for return types. Got it. Okay, how much time do I really have? I really have like 40 minutes, but I should probably do some prep for the meeting, so how about 10 more minutes? Is that enough to like set up stuff? Okay, so let's set up stuff. So right now we're in the unfortunate state that there's a C++ project with a CMake lists. We're going to over time change this into a pure Rust and like archive or delete this? Actually, that's a good question. When you port something from another language to if you port between two languages, do you keep the original, or would you archive it in a subdirectory, or would you just delete it because it's in the Git history? I kind of feel like until the Rust version meets and beats the C++ version, I gotta keep the C++ version around, and maybe even longer, because I might find a bug, and then to fix the bug, I might have to see, well, how did the C++ code do it? But I don't want this CMake list to get in my way eventually. So eventually we'd probably want to move it to a subdirectory and like not have the overall project build it. The alternative is I have two workspace directories and like I have two VS Code windows. Would that be better? Then they can't share anything, right? Unless I put stuff in a common sub module. Or a branch, yeah, branch. It's a good idea. But then like, if I want to have them side by side, I'd want to have like two workspaces, or one be a subdirectory of the other, right? Okay, I don't know. I guess I don't have to think too far ahead. First thing we want to do is make a file, right? Called cargo.toml. And this is a workspace, right? Because I imagine we're going to have multiple projects in it. And that's as far as I remember. So I gotta cheat and look at another workspace. So what do we got? We got the keyboard project. Fun. I actually made sure that this builds on the virtual machine, and I even reprogrammed the keyboard from the virtual machine, if you can believe it. And it didn't break the keyboard. This was last year's project, right? So yeah, we don't need that, because that you use if you have a different architecture for every component of the workspace. I don't know if we still need Resolver 2, so I'm not going to carry that, but this is really what I wanted, because I can never remember like the syntax. I remembered that much of it, right? I'm terrible at remember things. So I look at other things that I've written in the past to remind myself. So members, we don't have any yet, but let's make a new one. Let's just start with Lexer. Does that have to be a string? How do I get to the other window? Click here. That works. Yeah, it's a string. Okay. I'm telling you guys, my memory's terrible. So for that to work, I have to have a subdirectory called Lexer. And that should have a cargo toml, which I misspelled. Okay, and then that is can't remember. Because I usually have usually have that auto generated for myself. Let's look at the monitor for example. So it's package. Why don't we just copy this? Why don't we just copy it? Package, the name is Lexer. And we have no dependencies. Actually, we're going to add a dependency. We're going to depend on logos. I just need to look and see what version they're at. They are at version 0.13. Okay, so I will have a lib.rs. And let's try to do test-driven development. So to do that, I would have a config test. I know I could have like a tool auto-generate this, but my memory's terrible, and to reinforce it, at least make it a little bit less terrible, I try to handwrite stuff to as much as I can. It would be like test, right? Let's just start with something simple like numbers or integer. That's super simple, right? let input equal 42. Let output equal, and then this is where I got to refer to how does logos sort of work, right? We make a token lexer, so token lexer. Well, actually, I don't want to call it directly, right? I want to call my lexer is supposed to abstract away the fact that we're using logos at all. So this should be like just like lexer. Let's just presume that we can do a default. Well, hold on. Do we want to already have the bit stream when we create the thing? So it would be like new and then some kind of bit stream. So anything that can handle the data protocol or the data trait, and a string slice satisfies that, right? So then the output would be lexer dot next, I guess. Or let's just do lexer collect into a vector. And then because I'm gonna have lexers, I'm thinking that it should be like an iterator protocol, right? Caps are important. It needs to be cargo to toml. Really? Okay. There. That's probably why I didn't get any errors, right? Capitalization's important. Fine. Okay, so then we're gonna do assert, right? Equal. And I kind of like it being was it actual comma expected? Was that what I like? Expected actual, so expected first. Token. Integer. 42. Output. Okay, and then cargo build. This is gonna break, right? Build. The load manifest caused by. Oh, it has to be under source directory. Forgot about that. src. Move in there. Okay. What was it saying? Was it complaining that I should say it's resolver? Yeah. That's what I was suspecting. So that's confirmation, right? So here I should say that. Okay. Cargo build. Let's clean and then build. Make sure it's got no warnings. Look at that. It's all clean. The rest is so clean. So cargo test. All right, we haven't defined texer or lexer or token, so let's go and do that. The way this usually works is you use super everything, right? And then we're gonna have struct lexer, and then we want lexer to implement iterator. T equal token for lexer. Was that? See, this is the problem. If I haven't done Rust in a week, and I already forget stuff. Is that how you do it? This is not gonna actually. I think because we don't have we need to restart Rust Analyzer. Can you just restart, please? Restart. There we go. Because I like my Rust analyzer to be working. Okay, are you working? I think you're working now. Right, so we have to have a token. I kind of feel like they should be in a separate module. I'm going to try to get into a better habit of this. Instead of making monolithic code, I really should have it. This code should be for the lexer, right? So then there should be a, well, lexer is the principal class. I can still have a lexer.rs and I import that, right? Because then I want to separate. I want to have a token.rs. And I want lib to say use pub, use lexer, mod lexer, mod token. And then locally when we want to use token. Okay, so that means this moves. Or maybe I don't need a lexer submodule. Yeah, let's delete it. I do want token though. Okay, so let's define token. That's enum, right? And all we know about it right now is that it's going to have integer with I'm tempted to go up to 128, but let's just say 64 because we should be able to change our types later, right? Okay, so that needs to be public. Is it item? Is it iterator and then inside we have to say the type? Implement missing, yeah. So type item equals token. Okay, cool. Good evening, EverX. It's been a while. Have you seen the last 4 of the streams in this series? I should probably change the title, but most of the stream has been parsing GIF data using a parser that I wrote years ago and just trying to refamiliarize myself with it so that I can start porting it to Rust. So you missed it. I spent the last 5 streams making sure that this tool I wrote years ago can take this lovely file that you see there, which looks to the computer like this, and turn it into a report that looks like this. So that we can say like what every single byte and every single bit in the file means. Like that the header starts with GIF, it has a version 89A, all this good stuff, right? We can look, it can figure out what the width and height of the image are, 300 by 300, right? All that stuff. And the way that my tool operates, it's not coded specifically for GIF, but what you do is you describe the GIF format using a domain-specific language. Oh, my mouse wheel's acting up. Anyway, and the language is sort of a mix between a structure definition and functional programming. So, or not functional programming. It's a mix of a struct and a function. So it looks like it's a structure where it's declaring, here's the header part, here's the logical screen part, here's the trailer, but it also can have loops in there and conditionals and other things. So I spent the last 4 streams making sure that the tool works, fixed any bugs in it, and basically copied the syntax from like how it's defined in the specification from 1989. Like this is the grammar of a GIF file, and I basically coded that up, so to speak, in my domain-specific language here, and then got it to work and generated an output. So the first half of my tool is a compiler, right? Because I have my own language here. So the first step in porting this to Rust is to take that compiler and port it to Rust, right? So compilers usually have two sections. There's the lexer, which turns the text that you wrote into a stream of tokens. So like this is an identifier, that's a bracket, that's an identifier, that's a semicolon, right? Another identifier, semicolon, etc. Like reserved word, parentheses, literal, end parentheses. Those would be the tokens we want to get out of the lexer. Then from that token stream, it goes into a grammar analysis, like parsing, where it follows rules that you specify in a grammar and reduces it down to basically the compiled form of this, which would be an abstract syntax tree. You're going to watch the VODs? Just remember, just like any of my streams, there are like long spaces that are boring and then like some exciting points. Part of me wishes that I would remember to like hit a button somewhere like, oh, that was an exciting point. Let's make a bookmark so that when I do the VOD, I can have like here an index of the exciting parts in the VOD. If I were to watch my own streams, that's what I'd want. I'd be like, let's skip past the struggling part and let's just see the exciting parts. So yeah, anyway, that's what I've been doing, and now I'm turning to actually how I would actually do this in Rust, and we're looking at this crate called logos. So it claims to make ridiculously fast lexers, and who am I to argue? And it looks pretty self-explanatory, right? So kind of like in my flex specification, we're going to have like lists of regular expression patterns, and then basically tell it how to map that to tokens. So that's the logos way. In the old way, I would have had a sequence of pattern matches in code. So that looks, where is that? I should have pinned that. Formatting, this one, right? It kind of looks like this, looks more interesting near the top. Like here's a digit, here's an alpha. What's wrong with my mouse? Here are all the reserved words in the language, right? So if you see this literal string, then that's the token you return. Here's some more interesting regular expressions where an identifier we build off of the other. And that's the other thing is you can define patterns and then you can build off of those patterns in regular expressions to like say like this is an identifier, this is a floating point literal, etc. And so logos has a equivalent way of doing that, and I'm just learning how to do it, right? So like token probably matches these literals, right? And regex is more matching these rules that I have, like right here, like regex, right? People can disagree on what's exciting, that's true. So why not record everything, but then also off to the side have like an index of interesting moments. Okay, and I'm trying to do this with test-driven development. Like I wrote up at the test first, and now I'm just trying to get it to build. So the test kind of makes the assumption that we can make a lexer based off of a slice for now, and I guess we should say integer from slice, because we also might want to have a test that's integer from a file, right? And the second assumption is that the lexer uses the iterator, has the iterator trait, so we can collect on it. And we should be able to collect a sequence of tokens. And for this input, we should be, wow, my mouse is really screwing up. When I go left, it's actually going down and left. Maybe that's just the way I'm holding my hand. It's not the mouse that's broken, it's the Rymu. Yeah, so we should be able to get a stream of tokens out of the lexer, and the stream is represented by an iterator that gives us tokens. Cool. So then this should compile now, but fail the test, right? No. So we don't have a new, so we need to add that. Impl lexer function new. I wanted to like say that this is generic on some T, which anything that implements read input. And I don't like having single letters, actually. This should be input. So hopefully slice implements read, and this will just work, right? Self. Now I can make the whole lecture generic on the input, or I could make it box the trait object. Probably it's better to make it generic, right? So it'd be generic on some input. Okay. Actually, we don't need that yet because we're actually not going to store this. So it's just going to return self. Read comes from standard IO read. I like to do uses first and then mods. What's the error here? Oh, this has to actually return self. There we go. All right. What's the error? What's the warning there? Never used? I used it down here. Unless that's still an error. Okay. To work with asserts, we have to be able to implement debug on the token. So no problem, we can do that. Token. Hey, token, please derive debug. See, case matters. You can't compare vectors? Oh, because they're not comparable. So partial equal also. And might as well do equal. Kind of wish that the formatter would sort this. Okay, so I'm wondering if there's a way to like have errors be highlighted in the unit test, because I think it's because we're in configuration test, it's not highlighting the errors in here. Okay, I think I have one of my assumptions is wrong. I thought that read was implemented for a slice, but I guess it's not. Is it because it's a double reference? So I would remove that. Would it work now? No, it's still, so read is not implemented for a string? Is read the wrong trait? Am I getting my traits screwed up? It doesn't support generic readers. Logos only supports the inputs being slice. Oh, that's sucks. So, but my outer shell can support a reader, but I just don't think I have the right trait. There's something going on with me and the mouse here. So read might not be the right trait. What is read again? Let's get refamiliarized with what it is. It allows for reading bytes from a source. So that's actually what I want. And are there no implementations of it? Here are the implementations. Oh, is that right? You had to wrap it in a buff reader? You had to make a buff reader? Yeah, I think that was it, right? A buff reader can... Oh no, this is just buffering it. I thought there was a reader for a literal string. Am I wrong? not buff read. It's like, it's one of these, right? One of the implementations of read. Borrowed buff, buff reader. Buff reader just puts a buffer around it, but what if I already have it in a slice? Repeat sync split. Yeah, I don't see it here. Bytes? Oh, there we go. Yeah, that's what I wanted. Thank you, Spy the Man. I want bytes. So yeah. How do I get a bytes? Bytes on a reader. So that means you start with a read instance. I keep coming back to buff reader thinking like, isn't there a way to initialize a buff reader to like just start with bytes? Or do I make a buff reader and then like fill it with bytes? See all the things implemented. That's what I was looking at. That's implementers, right? These structs. Oh, I didn't read it far enough, I guess. Copy. That's not what I'm looking for. Not shown in the sidebar. Oh, really? I depended on you, sidebar. Implementers, here we go. File, TCP string, a slice of bytes. That's probably what we want, right? But how do we get a slice of bytes from a slice of characters? Oh, I know how to do that. That's a method of str, right? Yes. The type. Standard. I guess it's a primitive type. It's as bytes, right? Yeah. So that's right. So I want to do this way. I'd want to do input as bytes. There we go. That's all I needed. As bytes. Now let's see if in chat someone said that 10 minutes ago and I just didn't see it. Blah blah blah. We're talking about string reader. I think read is implemented for a slice of bytes. Yeah, byte. Okay, Spy the Man said capital bytes. That was close. But yeah, all right. Anyway, yeah, I have to keep in mind what Sarian said. Logos is not going to support the reader, so we have to do the reading ourselves internally, right? Okay, that's to make the test pass, but at least it builds. So right now it fails because we get like nothing out, right? Not yet implemented. It's not even implemented. Right. I guess we make the test pass, right? This is the most adversarial way to do test-driven development would just be to return, what is it? That we would have in here, we would have the tokens. So like, well, we would just have, the simplest would be to say, did we spit it out yet? All right. Bad with names. I need to get set up for my meeting too. Has output provided. Right? You guys are going to hate me for doing this, but this will actually make the test pass, right? We would say let output equal self dot output provided dot map. What is it? I thought I could, was it, it's then, I guess? Then. Then some. What's the difference between then and then some? Then some takes a type. So it would be then some token integer 42. There we go. That'll work. Self.output provided equals true. Output. That'll pass my test, right? Oh, it didn't. We got nothing out. Did I do this wrong? Oh, it should be, the semantics are wrong. Should be like, output not provided. What's a better way of saying this? Like, give output, and then that turns to false and it starts out as true. There we go. Pass my test. Done. We're done. We got our lecture, boys. Finished. That's right. So yeah, this is an adversarial form of test-driven development. It's like, if one person was writing the tests and someone else is just trying to be an asshole about it, they'd say, oh, to pass that test, all I need to really do is do that. I don't actually need to parse. Okay, my mouse, it really is breaking now. It's not moving right. So this would be really fun way to have two people fight and no longer be friends after a while. But yeah, the way you push back is I would make another test, like, or I would say like, I would just repeat it, right? And say that now it's 27, I should get a 27, right? That would force us to look at the actual input, right? So now we're failing it. But then the asshole would turn around and say, oh, wait, well, we can just like count the number of times that new has been called in a global variable. And the first time we're called, we're going to return 42. And the second time we're called, we'll return 27. And they'd be like, oh, okay, well, then then one way to do that is to like have two tests where you do it in the opposite order, or you have completely different values, right? And then now it becomes impossible for an adversarial lexer to actually pass this test without considering its input. Yeah, I need to go. It's at 10:35, so now is probably a good time to end. We're kind of wrapping down anyway, right? So there's no way I'll be able to like pass this test. I actually have an error. Defined multiple times? Is that because... Actually, why am I getting it multiple? Oh, because I have two tests. So this, I made it impossible to pass both of these tests without actually considering the input now, right? So there are other ways to do that, but yeah. So now I will be forced to at least look at that number, and so the asshole would turn around and say, okay, well, I'll take the input, but I'll just always call it an integer, and I'll still have to parse it, but I'll always call it an integer. Also, so then we would expand our test to have not just integers but floating point numbers, and then eventually your tests have to be so comprehensive that there's absolutely no way the asshole implementing it can't implement it incorrectly. So I'm gonna continue this development tomorrow, or maybe later today if I really want to. But yeah, we'll get there. Our goal is to parse this as a sequence of tokens, and then that'll be the lexer, and then after that we're going to do the parser, and then after that we'll have a compiler and we'll actually do the data crunching. So I'm so happy that you guys watched this long, and we're a great bunch of people in chat. Let's send you off to, I don't know. Oh, Tim's working on Ludum Dare. That sounds fun. We'll send you off to Tim. I will see you guys later. And hold on, I didn't see what that said. We can allow that. Start that raid again. Thing is, I'm using the interface that when I start a raid, I can't see chat anymore. Raiding Tim again. 5 seconds till I can hit the button. I'll take that 5 seconds to... Actually, I don't know what I'm gonna do. Anyway, I gotta go. See you guys later. Bye.